Oh shoot, I can't believe I left this up here during the quiz. That wasn't very smart. Oh well.
Oh, bummer.
Yeah. Okay, so the last question here in number 3, part 3, I want at the top of page 12, right where we left off. You have a picture that looks like this, and you are to sketch the inverse. Who remembers how we did this? We actually did this yesterday. So we take whatever the ordered pairs are. So this is 2, 0, and 0, 2, and negative 2, 0. And when we sketch the inverse, we switch them. So instead of plotting negative 2, 0, we plot 0, negative 2. And instead of plotting 0, 2, we plot 2, 0. And instead of plotting 2, 0, we plot 0, 2. So we end up with a picture that looks like that. That is the inverse. Do you remember doing that? Okay, so next time we meet, which I think is tomorrow, we're going to have a little bit bigger quiz over inverses in general. The reason I gave you that little one problem quiz is because last year on the test over this, everybody blew that question. So I wanted to make sure we emphasized it so that when it shows up on the test, you'll get it right. But this is a review of everything we know about inverses. Okay? So we're going to practice this, and tomorrow we'll have a quiz like this. It'll be like a real quiz, not just one problem. All right, so let's see how you do. Number 1. I'm on the side that says the first problem is this. And I'm going to find F inverse. Okay? Now listen, guys. This is easy. It's easier than the one you just did. Think of this as a Y, right? And then what? What's the first step? You switch the variables. So x equals 4y minus 7 over 3. Your job is to get y alone. This is a lot easier because there's only one of them. So what are we going to do if we want to get y alone? Multiply by 3. And then add 7. Yep, we're trying to get the y by itself, kids. Don't make this hard. This is easy. And then we will divide. So your inverse is 3x plus 7 over 4. Do you see how the process, at least the main idea, is the same as what you did on your quiz a minute ago? It's just a lot easier because on the quiz you had 2 y's to deal with. Here you only have 1, so it's easy. Just get it by itself. Okay? All right, number 2. Given this thing as shown, which, by the way, what is drawn there? What is this? Nope, not exponential.
Natural.
This is our natural logarithm function. So given the natural logarithm function is drawn, is it 1-to-1, why or why not? Okay, so I heard Caitlin say, yes, it's 1-to-1 because it passes the vertical line test and it passes the horizontal line test. In order to be 1-to-1, you must pass both tests. And it does, so the answer is yes. It is 1-to-1 because it passes both tests. You okay with that? Everyone? Okay. Now the last question we actually just talked about, it says draw or sketch the inverse of this thing. So what would be a good strategy Yeah. Some of you are too lazy and you don't want to take the time to do it, but I think it's worth your time to actually label all those points. So like 1, 2, 3, this is -4, 0, -3, -3. I actually like to label these. It takes a minute, but I stand a better chance of getting the right answer. If I actually label them. And yesterday there was some confusion. I suggest that when you start plotting these, and be organized about it, start at one end or the other. But so for example, I'm going to start by plotting 0, -4. And then I'm going to plot -3, -3. And then I'm going to plot 0, -2. And go ahead and connect those right now. If you kind of connect them as you go, it makes it easier. If you plot all the points and then try to connect them, you might get confused. So we have 1, -1, 0, 0. 2, 1, 2, 3. There we go. That's what it looks like. What do you think? Is that what yours looks like? Is that all right? All right, turn it over. We just did one, so we're not going to do that one again. But look at number 2. Let's at least talk about that on the back side. Given this function as drawn, which by the way, which one is that? Absolute value. Is this guy 1 to 1?
Nope.
No, because doesn't pass the horizontal line test. Remember, if you're 1 to 1, you pass both tests. You okay with that? All right, well, we're not going to do that rest of that side because we just did it and it's easy. All right, so tomorrow's quiz will look just like that, 3 questions, and we'll take care of that. Okay, so now we need to switch gears. And we're going to talk about something that you may or may not ever have seen before, and that is what we call parametric equations. Parametric equations. So I'm still on page 12. I'm still in section 1.5, but this is a different thing. All right, everybody with me? All right. So number 4 says, I've got these 2 equations, and these are called parametric equations. These are called parametric equations, and T is called the parameter. Now the question says, find the value of x and y if T is 1. Now don't make this hard. Do you have an idea? Plug in 1. So if I plug in 1, my x value would be 3, and my y value would be -3. That may be brand new to you. Did you put a pass? Okay. It looks complicated, but it really isn't. So let's try this one. This is number 2, or letter B. Same thing, only T is 7. Your job is to find the ordered pair. So here we go. let's plug in 7. So x is 2, and y is 49. Parametric equations are used a lot of times when there's 3 changing pieces to the problem. So for example, if a car is traveling, let's say this car is traveling, you have his position at any given time. So his position would be a coordinate, and then you have this time. So after 1 second, the car is here. But after 2 seconds, he is here. So if t is 1, you get 1 ordered pair. If t is 2, you get another ordered pair, and so on. However, graphing with 3 variables is complicated. So a lot of times, we don't want to have 3 variables. We want to have just 2. And that's what's happening in the next problem. The next problem says, find the direct algebraic relationship between x and y. That is a very fancy way of saying, write one equation with no t's. We want only x's and y's, so we somehow want to combine these equations into one so that we can graph it with 2 variables instead of worrying about 3. So does anyone have an idea? You know how to do this. You've never done it before probably, but you know how to do it. Emma?
You set x equal to y.
Well, I can't just set x equal to y like this. I can't do that. Oh! This is a system of equations, and you're talking about doing elimination and eliminating the t's. So one thought is, he says, look, if I multiply this equation by 2, I would have 2x equals 6t plus 2. And then if I multiply this one by 3, I would have 3y equal negative 6t. Now when I add them together, I have 2x plus 3y. Can't do anything with that. It's 2x plus 3y equal to 2. Now do I have one equation? And no, this is fine. You have done what the problem said. Now, could you rearrange this and say, oh yeah. But the directions said, give me a direct algebraic relationship between x and y. That means write me an equation with x's and y's. James Wayne, you with me? Now, he used elimination. Could I have done substitution?
No.
Oh yeah. So, for example, could I have taken, I love this plan, this is a great plan, but could I have taken, let's say this equation right here, and said t equals y over negative 2? And then what would I have done? Take that and plug it in here? Would that have accomplished the same thing?
Maybe, yeah.
It would. Now, would the answer look a little bit different? Yeah, but it's the same equation. It's just written differently in a different order. Emma?
Wait, so how, when we did did elimination, how did you, when you got 2x and then a 3y on bottom, how can you add those?
You can't combine them, but you can say 2x plus 3y. We do it all the time in equations. X plus 4y equals 12. And then you get y by itself, so you have mx plus b. This is just the standard form of a line. We do it all the time. You can't combine them, but that's perfectly okay. So, substitution or elimination. Let's try the next one. Give the next one a shot. Our parametric equations are x equals t plus 4 and y equals 7t minus 3. Now you can do this however you want, but I heard somebody say negative 7. So could I multiply this equation by negative 7?
Yes.
And if I did, I would have negative 7x equals negative 7t minus 28. Now when I add my two equations together, I get negative 7x plus y. These do not add, you just add them, equal to negative 31. There is one equation with x's and y's and no g's. That's all you have to do. It's that easy. All right, would you try C on your own? See if you can get problem C figured out. See if you can get it. This is what I got. Anybody else get this?
Yes.
No, I made the 2. Is it okay for me to do 2 negatives?
Mm-hmm. Yeah.
I made
So
the
then you had 3x minus 2y equals 14.
Yeah.
Same equation. Actually, fewer negatives, so it's even a nicer equation.
So if you do substitution, do we need to factor it out, or can we just leave it unfactored?
If you use substitution, it's okay as long as you get rid of any fractions you have. So if your problem ends up with a fraction in it, multiply through. So if you have something over 5, multiply everything by 5 to throw the fraction. Otherwise, it'll be okay. All right, everybody good with that? Okay. So I said we were going to do 3 different things today. So we've done 2 of them. Now we have the 3rd thing. And the good news is, turn the page. A lot of this is review.
There's a 1 question, but it's not.
All right, so here we go. A lot of this you should already know how to do. What does problem 1A look like? It's a parabola. 1A is a parabola. And where is it vertex? 0, negative 3. Kids, listen, if you didn't master this before, you better get it now, because you noticed all those papers I handed back to you were full of graph. You've got to know the difference between this, which is our problem, and this. There's a difference. Oh, that's B. Right? B is a parabola, but it is shifted how?
Right 3.
To the right 3. You have got to get that straight. And then what happens in C? It's another parabola.
1 down 2.
But where is C vertexed? Negative 1, negative 2. when you have x plus 1, that takes you 1 unit to the left, and then minus 2 takes you down 2. Now, number 2 introduces something we kind of touched on the other day, but now it's time to really hit it hardcore, and that is negatives. We know what pluses and minuses do. If you add and subtract in your problem, you are picking your picture up and putting it down somewhere else. Negatives flip you, okay? Depending on where the negative is how you flip. If the negative is out in front of the problem, then it flips you upside down. A negative in this position flips you upside down. The technical term is a reflection across the x-axis. You reflect across the x-axis. I think of it as upside down. So, letter B. The negative is out in the front, so that is going to flip upside down. So keep in mind what your original looks like. For the exponential, that's my original. If I turn it upside down, I simply take this picture and reflect it across the x-axis. So instead of that point being 0, 1, it's going to be 0, negative 1. And instead of coming in like the top of the x-axis, it's going to be at the bottom of the x-axis and shooting down. So that is a picture, that's this guy, folded over. So imagine you have a paintbrush and you blob some paint on here and then fold your paper. This is where the imprint will be.
Okay, so if we were to do something like this on a quiz and we wrote the original and then the other, would that?
Yeah, just shade that in so I know that's what I'm grading.
Okay.
Yep. Now, take a look at C. It is the same function and it has a negative in it, but what's different?
It's gonna
The
flip it
negative is inside the problem. It's not stuck out here in front. It's actually on the X. It's in the problem. All negatives are reflections or flips. If it's out in front, it flips you upside down. If it's on the X, I heard somebody say it, it flips you sideways. So this is going to go across the y-axis. So again, here's my original. I'm going to dot it in. If we take this thing and fold our paper this way, that is going to be over here, and that is going to be up here. Does that make sense to you?
Yeah.
The heavy black line is the answer. A negative on the X folds you this way. Jalen?
Why wouldn't you make it 1 over e to x out?
You can, but that makes it tougher to graph. If I know how to handle a negative X. If you said graph this, I don't know what that looks like. I mean, do you know what that looks like? No. But when I write it this way, I know what it looks like because I know what e to the X looks like. But it absolutely is the same thing. It is. All right. How about D? Can you sketch D?
Yep.
What's it look like?
Negative 1, 0, and then flip it.
It's a parabola. It's got a vertex at negative 1, 0. And it goes down. It's upside down. Perfect. Nicely, nicely done. Look where that negative is. It's out in the front. have y equals ln negative x. Pay attention to where the negative is. This one's going to go sideways, right? So think about what your real logarithm looks like. That's what your normal logarithm looks like. But we're flipping it this way. So this is going to be the point negative 1, 0. And it's going to look like that. And one more. Negative ln. We gotta be able to keep these straight. These are different things. This negative is out in front. So what do negatives out in front do? Upside down. So here's the original. I'm going to start with the original. That's my original logarithm picture. Now I'm going to turn it upside down this way. So that is actually going to be up here.
Yes.
And that is actually going to be down here like this. So the heavy black is your picture. It's the dashed one turned upside down. Everybody good so far? Because we're getting ready to start the heavy duty action here. Everybody's watching the clock. Oh my gosh, let us out of here. Oh, we still got tons of time. Sit back and enjoy it. All right, I'm going to get you some graph paper because we're going to start sketching some things. Okay. So we'll take a couple of pieces of graph paper here. And we're going to start graphing. So take a couple pieces, Magnus, July. Just take a couple, pass them on. All right, so here's what is going to happen now. We just practiced flipping and moving our BFFs, some of our BFFs. Now you're going to practice all the same skills, but with a random generic function that I have just totally made up. So we're going to take this picture now. Yeah, you don't have to rewrite this. You have it on your paper there, so you're good. You don't have to draw this unless you want to. All right, so here is what we call f of x. So this is our base function that we are going to start with. And then we are going to do all of these things. There's a whole bunch of stuff going on there, so we're going to do all of them. All right, so you're going to sketch this. Now that's easy if you remember what a negative out in front does. A negative out in front makes you upside down. So you're going to draw that picture upside down.
Can you write the
What? So we're going to flip it upside down. So some of these points aren't changing. But this one, instead of being down here, is now going to be up here, right? And that one's going to be down here. So that's what I got. You're gonna get lots of practice with this, so be patient with yourself. Everybody okay? Now, look at the next problem. The next problem says use the same picture, but now we're doing f of negative x. Notice the negative is now inside the problem. And when the negative is inside the problem on the x, it's not an upside down flip, it is a sideways flip. So anything that was on the left in the original is now going to be on the right and vice versa. So this little triangle thing right here, he is over here now. That little triangle is now over here. Does that make sense to you? And then similarly, all of these triangles are now going to be over here. So you just take your time and think about what you're doing. You're taking everything from the left and putting it on the right. Same size, same shape, same everything, just now it's on the other side of the y-axis. So this little triangle comes over here, this one comes over here, this one comes over here. Taylor?
We never got graphic paper.
Well, I don't know. I handed it out and said pass it around. Take a couple pieces. I don't know what happened to it. Everybody okay with that one? Here we go. Next one says f of x plus 2. Okay, this is f of x right here. So we're going to take that and do something to it. What does the plus 2 in that position, what does that do? Up 2. So every point is going up 2. So this guy right here is going up 2. Up 2. Up 2. So now that triangle is up here like this. Up 2. Up 2. Up 2. So every single point, and you can do it point by point, goes up 2 units from the original. Everything goes up 2. Everybody good with that one? Everything up 2? Alright, now take a look at the next one. Magnus, take a look at the next one.
Everything's
Everything is going left too. Can everyone see that? Notice where the +2 is. It's in the parentheses with the X. And that's going to shift everything in that picture 2 units this way. So, I don't care where you start. You can start with this point right here, or you can start with that triangle shape. I'm not sure what your favorite strategy is, but you got to shift everything 2 units. So right now it's at -3. So it's going to be all the way over at -5. So there's that initial triangle, shifted 2 units over. There it is. Everything shifted 2 units to the left. Good? Next, oh my goodness, now we're doing more than one thing. Now 2 things are happening. Some of you are going to be able to do both things at the same time. Personally, I'm not able to do that. I have to do one thing at a time. So I remember PEMDAS, and I do what's in parentheses first. So I'm going to do this first. What is that going to do? Which way? Which way?
Right one.
Right. That's going right one. So I'm going back to my original picture, and I am taking everything right one. Right one. So everything is going right one. So this is my original picture with everything shifted to the right 1 unit. Now what do I have to do? See that negative out in front? A negative out in front turns me upside down. So I'm going to take everything I just drew and I'm going to flip it upside down. So it's going to be up here. This is going to be down here. This is going to be down here. And this is going to be up here. Now, because I have the magic of the blackboard, or the whiteboard, whatever, I'm going to go ahead and erase that original so it doesn't confuse me. You can leave it or erase it, it's up to you, but make sure the one you want me to grade, your final answer, make sure it's heavy, you know, like shaded heavy or something, so I can tell this is the one, the main one. Do the other one light or with dashed lines or something. Is that good? We're going to do one more. One more. We're going to do F. So here we go. 2 things are happening in F. What is happening in F?
Down 3.
We definitely are going down 3. And what's happening here?
Flipping.
Right.
We're flipping. Negatives always flip, but this flip is sideways. So we're going to do a sideways flip. And this is going down 3. Sometimes when I have a lot going on, I make notes to myself so I remember. So let's do the sideways flip first. If you can do both, that's fine. I'm going to do them in stages. So I'm gonna do the sideways flip first. So the sideways flip is going to take after you've drawn this shape a few times, you start getting used to it. So there's my sideways flip. Now down 3. And the purple is my answer. Everybody okay? Well, we'll pick up there tomorrow. Remember, we have a quiz tomorrow over the inverses, like that practice quiz I gave you. Have a wonderful day.